I would like to welcome everyone here for this presentation. My name is Lucky Mwila, coming from oxygen plant section. We are going to do power plant and oxygen plant management. Then we will also look at safety management at oxygen plant. We also have a look at our process introduction and production. Then we also look at how we are managing our machines. And lastly, we look at how we are promoting localization. I would like to understand a few words that we are likely to encounter as we go down our presentation. Firstly, we have these machines which we call blowers. Blowers are basically machines which need to blow in air. Then we have got vacuum pumps. Then we also have oxygen analyzers. Basically, these are helping us manage look at the oxygen that we are producing. Then we have got the oxygen buffer tanks. They are basically storage tanks for oxygen. Then we have got the towers. This is what we call our towers, is where our process do occur, which is adsorption as well as absorption. Then we have got pumps. We have got liquid pumps such as liquid oxygen as well as water pumps. Then we have got what we call the oxygen systems. In our plant, we have got what we call part 1, 2, 3, 5. Basically, they are systems which help us produce our oxygen. We have got the molecular sieves. These are helping us in our process to achieve the production of oxygen. We also have got air dryers. These are basically helping us with the removal of moisture from our air. Then we have got our compressors. Our compressors are basically helping us with the raising in of pressure. We have got different types there. We have got the air, the oxygen, as well as the nitrogen. Then we have got what we normally refer to as instrument air. This is basically the air that we are trying to use for our special valve operations that we give to our clients. Then we have got the general air, which we normally also produce from our screw air compressors. As the name suggests, they are for general use purposes. Then we have got the machine vibrations there. Basically, this is talking about the actual movement of the machine, be it in the stationary or motion phase. Then we have got the VPSA. Normally, it's a short for vacuum pressure swing adsorption. Then we have got what we refer to oxygen flow. Basically, it's the oxygen that we are giving our clients. Then we have got the oxygen vented. This is the oxygen that we produce, but we take it back to the environment. Then what we call the oxygen neutralized. This is what our client has used. Then we have got the oxygen purity. Basically, this is the amount of oxygen in the air that we are giving our clients. Then this word regeneration. Basically, this one is just giving a new life to the process to regenerate. Then we have got this sage, machine sage. This is the instantaneous experience of the machine in the actual normal operations in terms of vibration and other factors. We'll look at our management system. We currently belong to power plant system in terms of our management. Currently, we are standing at 55 in terms of personnel as the established figure from HR section. But the current number is standing at 54. Our personnel in terms of 4 operation classes. One operation class comprises of about 7 personnel as well as the maintenance team. I'll take you through how we are doing our safety management. Generally, we are generating weekly as well as monthly reports, which we strictly follow to achieve our safety goals. Then our safety issues are generated by these classes when they are doing safety inspections, as well as our monthly inspections. Our safety representative on a daily basis is assigned as a man in charge to see that all these duties on a daily basis are tackled one by one until we achieve them. Our plant was the highest scoring plant. So meaning our safety management system is on course for us to achieve this result from the external auditor, which was injected in by the company. These safety signs, they demand that you strictly follow our safety regulations once you arrive at the gate of our plant. The safety precautions still continues for our plant. we do make sure that forklifters and trucks entering our plant do not have oil spills as they enter our plant, because in our plant we don't like oils. Then the people entering our plant must declare the cigarette, matchsticks and other flammable materials at our gate. Every people entering our plant must sign so that we know who is inside our plant in case anything happens in our plant, because it is extremely dangerous. All private vehicles, we do encourage them to stop by the gate. We are saying oxygen plant currently comprises of the main oxygen plant, which has got part 1, which is 8,000 and 4,000, then part 2, part 3, part 5, which are all 8,000 systems. We are also saying that small oxygen plant is part of our plant, but this plant is a cryogenic. Then we also have the nitrogen plant as our third plant, which is a CCS system. Then we also have the blower section, which we are housing the keke blowers, the screw compressors, the fresher blower as well, that side. Then our acetylene plant, we are just saying care and maintenance, because we are no longer producing acetylene, but our equipment is still there. So we are still caring for our equipment. So we are saying that our main oxygen, its main function is to supply oxygen to ice smelting furnace for copper smelting purposes. Then the small oxygen is there to supply cylinder bottles to 2 electric furnaces, anode furnace, and the equipment for construction purposes use. We also do have the nitrogen plant. Its purpose is to manufacture and supply nitrogen to anode furnace. Then we have got the blower section, where we are supplying the blowing air to ice as well as converter blowers. Then we are also supplying compressed air in terms of instrument as well as general. Then we also have the fresh air blower there, which we are also supplying. Oxygen plant, basically, they are all air separation systems. We are saying oxygen plant and nitrogen plant are all PSA system. In the production of oxygen, we are using lithium-based oxygen molecular sieve for oxygen production. But in nitrogen, we are using the carbon molecular sieve. Then the small oxygen is a cryogenic plant, which separates the oxygen and nitrogen by the use of this factor, the different boiling point. The small oxygen product is obtained as a liquid. In our main oxygen plant, we are obtaining the oxygen as a gas. In a VPSA system, you basically have air coming in your system. Then this pre-treatment stage, all you want to remove is the dust and other big foreign particles from there. That's where you inject in the air filters. Then your blowers there will try to do your pressure so that you can inject in your system now. In the system there, the process of adsorption will take place in the towers. But these valves are powered by hydraulic system. Currently, we are using the hydraulic system. You store them in your buffer tank there. The buffer tank is only to store your oxygen. Yeah, but because in your process there remained a lot of impurity or nitrogen, that's where now your vacuum pump comes in to get rid of that, vent it out of the system. Then your compressor there will do your job to about 225. Our clients there, ISA converter and anode furnaces, will receive the oxygen. So this is just a simple process in terms of VPSA. But going into detail, we looked at the adsorption. Your blower will just pump in your air there. As we have said that tower A, we want tower A to give us oxygen. In the oxygen, that's where you are going to have your lithium-based molecular sieve. Currently there, the activated alumina there, we are using the 13X. That one is there just basically to counteract much of your water. This one is very good at touching your water. So the moment this one starts failing to attack your water or remove the water, then your lithium-based oxygen molecular sieve will easily lose its power or efficiency. Then the porcelain balls there, they are just there to protect much of your lithium-based. Your oxygen there will be produced going to the tank there. Well, this one was being cleaned, removing nitrogen, venting out. So now tower B will receive the air there. Just the same process we looked at in the previous page. That's why this process, just to simplify it, it's called the VPSA, pressure swing adsorption, because your towers are changing. Well, this one is working, another one must be cleaned. So the minimum number of towers you can have in VPSA is 2. So we'll look at the production capacity. Our actual capacity is standing at 33 nominal cubic meter flow per hour with an average spirit of 89. For pressure, we are standing at 225. We will look at the 4,000. It can only give us around 3,000 with about 87. The part 1, 8,000, can give us about 5,000, 85% oxygen purity. Our part 2, part 3, they at least are trying to give us as much as that. Our part 5 recently came online there. This one is able to give us a lot of oxygen with very good purity. They are at 90, almost 90%. We'll look at some of the machines that we are using in VPSA. We have our centrifugal blower there. We have our rotary blowers. As we said, there are different kinds of blowers. We have our compressors there. We have our towers there, our vacuum pumps there. Then, of course, our oxygen analyzer and our oxygen buffer tank there. For small oxygen plant, this is the separation of oxygen and nitrogen. Because of them having different boiling points, the oxygen has got a higher boiling point than nitrogen. Usually nitrogen try to set on the upper part of the column, while the oxygen is collected on the down part of the column. So basically the process starts with an air compressor. After an air compressor, we have got our cold dryer. Then we have got our absorbers there doing the hot drying. Basically, this one will remove a lot of water, but still there will be about 10% of water coming there. The liquid oxygen will settle at the bottom because of different boiling points. It has got a higher boiling point there. The nitrogen will set on the upper part. Then our liquid oxygen pump there is helping us to get the liquid oxygen to the pump, of course interacting with the heat exchanger there. Then by the time we are filling in our cylinders there at 12 MPa, we expect the liquid oxygen to be gas. So these are some of the machines that we are using, small oxygen. We have got the compressor there, the pre-cooler, as I said, the absorbers there for regenerating that nitrogen comes there to help us remove much of that moisture. That is our liquid oxygen pump. That is our small oxygen, currently the small oxygen house we are using. Then this is our filling bed where we are loading in our cylinders there. At small oxygen, we have got safety precautions that we do normally follow. We do not encourage the cylinders to be rolled on the floor. When you are taking to our plant, you transport the cylinders in a kg. Then these rubber rings that we have introduced on our cylinders, they are not supposed to be removed. We do encourage that the people using the oxygen cylinders and the acetylene cylinders do place them 5 meters apart. They must always, all the time, have the fire extinguisher nearby. The oxygen hose as well as the acetylene hose should have flashback arresters, as they are good. Once there is fire on the other end, the fire will not get into the cylinder because of the help of the flashback arresters. Then we are saying all empty cylinders onto our plant must first inspected by our gatekeeper. Our gatekeeper makes sure that he inspects our plant to be free of oils and any valve maybe damages and the like. Then our operator there, normally before he loads in, he has got the inspection which we call the cylinder safety checklist inspection. He makes sure that most of the items which we prescribe there are followed for the safety of our plant. Now we have got a total of 1,500 oxygen cylinders. Encourage that our cylinders remain in good condition. We have now decided to give them codes The I code stands for ISA. Then the SP code is for the supply section. The RIF code is for the reduction furnace. Currently, we have got 300 for ISA. RIF also has 300 cylinders. Then the remainder is under SP section. We are also producing nitrogen. Currently, we have got this one, which is doing about 400 cubic meter flow per hour with about 99.9% nitrogen. This is injecting the use of carbon molecular sieve, which have the interest of producing nitrogen. As you can see, we'll begin from there. We have got our screw compressor there. We have got the pre-cooler there, removing the water. Then we have got the PSA system there, which is carbon molecular based in this tank with the interest of producing nitrogen there. Once nitrogen is produced there, there it is just a matter of compression. Then we can give it to anode furnace. Blower section, we have our KK blower machines there. We have got our 2 ISA blowers and 3 converter blowers there. Mostly these KK blowers, their pressure is proportional to your IGV opening. It is not observed. This machine usually sages. Observe that this red line, mostly when we are giving to our clients, is not closed. Once it is closed, this machine do sage. As we said, sage it is an abnormal or short experience of abnormal vibrations or different factors within a shortest period of time. This is very dangerous for the blower as it can damage our blowers. So we do not encourage that this sage factor comes in this section. That is where we are doing our oxygen air mixing there. As you can see, this small line there is our oxygen line. Then this is our converter blower line. The two are mixing there to give a converter section there. In this section, the blower section, we do have a total of about 5 M250 screw compressors. So the M250 screw compressors in total we have got 8. Then the M55, we have got about 4 of them, each with a capacity of about 9.1. In this section, that's where we are also supplying the pneumatic air, which is instrument. We are always observant that we reach the mark of 700 kPa. As it is safe for our blowers, the boilers, as well as the KK blower machines in terms of supplying the instrument air there. We are also supplying the general air in this section. We are observing that for the general air, we stay at 650 kPa. These are basically some of the machines, the M250, our dryer there, as well as the demonstration of where we are using our instrument air for opening and closing of our pneumatic valve. Currently, all our line or our drawings now, the valves are tagged. We have all the valves, critical valves supplying our clients, they are tagged. We are using the green one for the general. Then the red ones, they are for instrument. So now, our clients, if they want to make a new line to the existing line, we are encouraging that they fill in a form and apply it to the main control room. Our fresh air blower there is supplying our control rooms with fresh air. Our smelter substations there are being supplied by that machine with the fresh air for cooling purposes. We look at our inspection management development. So we have got a lot of machines in our section, but we have developed a maintenance team, which we call a professional maintenance team. These guys are not only able to inspect, they are able to troubleshoot, and this guy is able to repair complex machines. So they belong to this group, what we call professional inspectors. And currently we have 3 of them doing 12-hour shift. They are very, very special guys. We have seen that there is a reduction of about almost 50% in terms of our plant downtime as compared to valve problems in 2022. So, which is a great improvement with the introduction of this team. In our inspection management development, we also have developed a ticket, which is we call our oxygen plant professional inspection. This is the paper or the copy that the guys do use to critically monitor our machines as the professional inspectors. Our machine development also continues in such a way that the greasing schedule, which can be monitored from machine to machine with the use of our database, this equipment management database, whereby each and every machine you can track it. When maintenance was done 2-3 years ago, you are able to track and be able to critically look at its position. We will look at lastly, how are we promoting localization? Previously, our Chinese used to work in the night shift, but starting from 2019, only Zambian people have been working the night shift. But to promote that, we're also injecting the logbook. That logbook is accessible to both Chinese and Zambians at each and every time, so as to monitor how our plant is doing at each and every time, as well as the WhatsApp group. The WhatsApp group is there also to assist us. We have this, how is our departmental structure during night shift. So during this shift, we have got our foreman, who is in charge of both production and maintenance. These assistant foremen are doing 12-hour shifts. Then these class supervisors, together with their team of about 6 members, as we looked from the first page there, is assisting the foreman in terms of our production. Then the professional inspector guys who are doing the 12-hour shift, those 3 guys, they are helping the foreman there with our machine inspections. With your attention and from what we have briefly discussed, I would like to thank everyone for paying attention to my presentation.